Hey, I'm Lakita Vijayaratne from the University of Texas at Dallas, and I'm presenting on machine learning calibrated low cost sensing. Globally, air pollution kills an estimated 7 million people every year. Taking into account WHO's data, 9 out of 10 people breathe air that exceeds WHO guidelines and contains high levels of pollutants. Gathering data on air pollution is the first step in mitigating air pollution. This is usually done with expensive regulatory sensors whose deployment is naturally limited by their cost. Observations of air pollution show a lot of variability on small time and space scales, highlighting the importance of being able to deploy a number of low cost sensors to make accurate measurements every few seconds 24/7. Taking this into account, we have built, calibrated, and deployed a large number of sensors across the Dallas-Fort Worth Metroplex in Texas. Essentially, we designed two sensor systems, the central node, which is on the left, and the LoRa node, which is on the right. The central node carries all the bells and whistles that we might want in a sensing system like this. In contrast, the LoRa nodes comes in a smaller, more compact package and remain as simple as possible. The LoRa nodes are quite versatile and they do not require direct power or internet connections, and thus they can be placed anywhere we need. These sensing systems actually work in tandem where all the data collected on the LoRa nodes are transmitted to the central node using a technology called LoRa, which stands for long range communication, and they only need to be within 5 kilometers of the central node. We essentially are planning on building 10 networks of sensor systems where each network carries one central node and 10 LoRa nodes. These sensor systems are being developed by students including graduate students, undergraduate students, and high school students. The designs as well as the codes can be easily replicated, and our designs are open source and can be accessed through our GitHub page as well as our wiki page given here. Our approach is being replicated by the European Space Agency and is slated to be implemented in 45 different countries soon. The accuracy of the sensing systems goes down as the cost goes down, as one might expect. Machine learning can be applied to address this issue with low-cost sensors co-located with a reference sensor for 6 months for training machine learning algorithms. Once trained, the low-cost sensors that we build can be mapped to the reference sensor with remarkable accuracy. Once calibrated, the air quality data of each sensing system is posted on a public portal made by senior design students at UT Dallas. Also available are climate data such as temperature, humidity, pressure, as well as air quality data taken from various other sources like the EPA itself. With the assistance of local communities, we work to reduce air pollution. One such group is Downwinders at Risk, which is based at Jopa, Texas. Jopa is surrounded by multiple sources of air pollution. We deployed one of our sensors at Jopa, and we were part of many community outreach programs on air pollution organized by Downwinders at Risk. This is some of the data collected by the sensor which is situated at Jopa. In order for us to combat air pollution in a public and a proactive manner, we strongly feel that we should make people aware of the problem as it exists. As our sensor systems become more and more frequently deployed throughout the Dallas-Fort Worth Metroplex, they are attracting a great deal of media attention. Through the data we provide and the research we conduct, we hope that more effective air quality regulations might be achieved for the betterment of the general public. My final words go out to our team at UT Dallas as well as everyone who has contributed to making this project a success. A big thank you to all.